Okay, section 2 really builds on section 1, so this should be much shorter than section 1. Thank you. First off, just kind of a quick review on some things. An exponent, remember, that's our small number raised up to show how many times a number is being multiplied by itself. So for example, if I had 4 to the third power, your exponent would be the 3, right? It's saying that I'm taking 4 times itself 3 times. So like 4 times 4 times 4, which is 64, okay? Remember, it's not 4 times 3, it's saying how many times does it take it times itself. And the term factor, well, this 4 right here, that is the factor. Factor are basically numbers that are multiplied. Numbers that are multiplied. And if you remember, going back to your elementary school days, the answer when you multiply is your product, okay? And in the book, it's probably going to ask you sometimes to write something in exponent form. Exponent form. If it asks for exponent form, well, guess what? That means it should have an exponent. So this number right here, 4 to the third power, is in exponent form, okay? This 4 times 4 times 4, this would be written out with factors. Okay, that's kind of the difference with the terminology. So first thing that you might see, it says rewrite the expression as a repeated multiplication in 3 ways, using x, a dot, and parentheses. Well, first thing, let's not use the x. Okay, let's get away from that. We just never want to use an x for multiplication anymore. It just kind of gets confusing. If we use an x, it should be used as a variable, especially with coordinate planes. So really we're only going to do what? 2 ways. With a dot and with parentheses. So this is 3 to the 4th power, which means we're taking 3 times itself 4 times. So I can either write 3 times 3 times 3 times 3. Okay, that's using the dot. Or I can do parentheses to show multiplication as well. So I can say 3 times 3 times 3 times 3. Could I have parentheses around the first one? Sure. It doesn't matter. Usually we don't write parentheses around the first one, but you can. So anytime we have parentheses, the operation in between them is multiplication. Anytime we have dots, kind of in like that midway point, that also means multiplication. So let's get rid of using x's for multiplication. That's all you have to do for those 2. You also might see where we want to write something in exponent form, like take a number and see if we can write something in it. And this will really help us down the road, especially once we get into Algebra 2 and start working with logs and things like that. So for example, it says, like if I had the number 125, I could rewrite it as 5 to the third power, right? Because if I took 5 times 5 times 5, I would get 125. So let's think about the number 32. So I have 32, and I want to write it as something with an exponent. Well, my best way to think about this, if you have trouble figuring out where to start, is it's going to be some number times itself. It could be times itself 2 times, or 3 times, or 4 times. So I try to think of it as, like, what number multiplies by itself that's really close to 32? Well, 5 times 5 is 25, and 6 times 6 is 36. Those are really close, but they're not 32. Well, for my base number here for that factor, it's got to be a number smaller than 6. It has to be smaller than 6. And why is that? Well, if I start with 7, I'm multiplying it by itself, right? So 7 times 7 is 49. That's already bigger than 32. So that wouldn't make any sense. So then I start thinking about things that are smaller than 6. I might try, well, we already showed that 5 times 5 didn't work. If I multiply by 5 again, I'm at 125. So I can do 4 times 4, which is 16. That's still short. What if I multiply by 4 again? 4 times 4 times 4, right? That'd be 4 to the third power. That would give us 64. Well, that's way too big, okay? So that didn't work. So hopefully some of you are starting to see where this is going. But even if I did 3 times 3 is 9. If I multiply by another 3, I'm at 27. Obviously, if I do another 3, I'm way too much. So I'm guessing it's going to be a 2. So it is. It's 2 to what power, though? 2 times 2 times 2. How many times would that have to be done? And you might have to use a calculator. That's okay. So if I do 2 times 2, that's 4. Times 2 is 8. times 2 is 16 times 2 is 32. So how many 2's is that? 5 2's. All right, 1, 2, 3, 4, 5. Okay? And that's the thing. It might take some people, 5 seconds to think of that and write their exponent form. And it might take a few people to actually write some things down. It doesn't matter. Work at your own pace. Realize, am I somebody that can do things mentally? Or am I somebody that needs to write my steps down, need to write my work down in order for me to figure it out? Okay? Either way is perfectly fine. Another thing, just like we did the other day, it says do the calculation. Check your results with a calculator. So I want you to try this without a calculator first. Okay? I'll be walking around, I'll be checking it out, making sure they're not using it right off the bat. So if we take a look, we have subtraction. Well, think about that rule we talked about yesterday. You need a common denominator for subtraction. So I'm not going to, if you can do this mentally, have at it. I love that. Right? If you're good with your fractions, that's great. And for those of you that are good with your stuff mentally, you can think, well, I'm at 5, which is a whole number. If I drop down the 7th, or any 7ths at all, I'm dropping down to the 4 whole number, right? And if I take away 2 7ths, that brings me down to 5 7ths, right? So if I went from 5, if I drop down the 7th, I'm at 4 and 6 7ths, right? If I drop down another 7th, I'm at 4 and 5 7ths. That's kind of how I think of it mentally. All right? And everybody's a little bit different. So if I did this mathematically, I'd have to make 5 into a fraction, right? Which is over 1. And for a common denominator, I'd have to multiply by 7 to get it to 7. Which means I have to do the top by 7. So it's really 35 over 7 minus 2 7ths, which I'd get 33 7ths. And I'm okay with either answer. Depending on what you're using it for, you might keep it improper or keep it as a mixed number. Either way is perfectly fine. Okay? And then try it with your calculator. Make sure you can use your calculator. That's important, okay? And lastly, this is where it's kind of building on some stuff from yesterday. It says at stage 1, 5 new branches are growing. How many new branches are there at stage 2? So in stage 1, I got 1 branch. In stage 1, I have technically 6 branches, right? I got this big one. But I got 5 new ones. 1, 2, 3, 4, 5. So a total of 6. Write the total. But it went up 5, right? Do you think it's going to go up 5 again, or will it be more? Looks like more, isn't it? I could physically count this, but maybe you're starting to see a pattern. Right? So basically all it did was, each of these sticks that we had, it made 5 juts off of it, just like it did in stage 1. So if I look at that stick right here, it just made 5 more juts off of that. And how many of those 5 juts do we have? 5 of them. So 2, 3, 4, 5. So really we added 25, didn't we? We added 25 there. So what's our total now? We'd be sitting at 31, right? So if I think about this, what do you think stage 3? How many do you think we'd add on stage 3? Well, we're working with exponents, right? So right here, from stage 0 to stage 1, we really went up 5 in the first power, right? That's how many we added on. We added 5. From stage 1 to stage 2, we added what? 5 to the second power, because we had 5 sticks, right? We had 5 big sticks with 5 little sticks. And now we're going to have 5 big sticks with 5 little sticks with even 5 more smaller sticks. So guess what? We're going to go up 5 to the third power, which is 125 more in that case. But really it was asking for what? How many new branches are there in stage 2? Well, there was 25 new branches, or I could have written it as 5 in a second. So there's your answer, but take a look at that pattern. So when it keeps building off each other, that's kind of our recursive rule, right? It's going up by a multiple of 5 each time. We see that? So I could really say the recursive rule if I wanted to write one for this. Could say multiply by 5 each time. That'd be perfectly fine. 5. Okay, just something like that. All right, so built a little bit off of yesterday, and then we'll kind of do that same thing leading into tomorrow.